Hello, Maurits here again. Welcome to this second video about the normal distribution. And just to recap, the normal distribution is a distribution of a continuous variable. And if you would plot it, it would look something like this, where on the peak here you have the expected value or the expected average. And out here at the inflection point we have +1 standard deviation and -1 standard deviation. And secondly, we have to remember that the area under the curve from some value A to some value B is giving us the probability that we are in between A and B. And normally we write our random variable as a normal distribution with some expected value, some average, comma, the variance that is the standard deviation squared. But quite often in the problems you are just given the standard deviation. So say for example you have some kind of, say, a puzzle. The student solves a puzzle and we have found that the average time for a student to solve a puzzle is 36 minutes with a standard deviation of 6 minutes. And we are to calculate what is the probability that a random student will take more than 40 minutes to solve this puzzle. So what we do, we go into the calculator. By the way, the one I'm using here, right, looks a bit different because it has a bit more functions than the one I used before. So we go in here to stat mode, distribution, normal, and we will basically always use this one, and we will see this one use that as well. The first one we will never use. So we go in here, see to that we have variable here. Our lower value, since we're talking about the probability to get above 40, so we take the lower value as 40. Upper value, we take some very big value. I usually take 9x99. So we put our standard deviation at 6 and our expected value as 36. And we do the calculation and find that the probability is 25.2%. But suppose we had a question that was in the opposite way. We say the probability that our random variable is larger than some unknown value, let's call that V for value, is equal to 25.2%. And now instead the question is to find V. In other words, for what value will the probability that X is larger than that value will be 25.2%. So if we draw the curve, we are basically asking this, what value V will this area here be 25.2% or 0.252? And that is basically doing this calculation backwards. And happily enough, the calculator has a tool for that. So we go in here to distribution and the normal distribution again, and we can guess that we should use this one, right? The inverse normal distribution. And first we set this var again, and then the first question or first thing we need to add if we're talking about right tail or left tail. And that is basically it's this part that we look for the probability is that sticking out in this or that direction. So now we have a right tail, so we need to change that to right if it says left. Center means that we have the probability is between one to the other, and we can look at an example of that in a minute. Then we enter our percentage 0.252, and then we simply calculate, and we should get our 40 back. So in other words, we could get this value V from the percentage, or in the right calculation we could find the percentage from this value that we have, so X is larger than 40. So we can work with this in both directions. So say the question is here, how large should a value V be here for us to hit the 90th percentile? The 90% should be able to do it up to that point, which means 10% would take longer time. So we can set v equals to the probability for this to be equal to 0.1. That means that 10% will take longer time, 90% will take shorter time. So go in here again and change this to 0.1 and do calculation, and we see that v will now be 43.7 minutes. So 90% of the students will be finished before 43.7 minutes, and 10% will take longer time than this if the distribution is normally distributed. So what's about this center thing? We can ask a question here that in between two values, so the average minus some value v and the average plus some value v, this inside here should be 80%. So 80% should be able to fix this between mu minus v to mu plus v. So we go in here again, we change this to center, change our probability to 0.8, keep the values we had before. We found here that that will be 28.31 and 43.7. So that is the two values here, 28.3 and 43.7. Oh, that's the value we found up here, right? Because we previously calculated that this area over here, we should find that when that was 10%. And of course, by symmetry, remember that the normal curve is symmetric. So if you have 10% over here, then that's 10% over there too, right? Because we have plus minus that. So we should expect to get the same value back. So that is for the center calculation. Hope this helps a bit. Thank you.